Whew, so here we are close to the end, last few steps. I've made some changes to drawings to reflect the design decisions that I've changed along the way. There's some interesting tools I had to make to get things set up for this project to do the last few steps. And there'll be a test at the end. So let's just get right to it. Hope you enjoy. So I want to counterbore these, drill all the way through, 1/4 inch, counterbore for 1/2 inch, I forget what the diameter is, slightly larger, and knurl this edge. But the first thing I need to do was stick them in my split collet I made, put it in a 4-jaw chuck and dial it in. It's pretty good. Took about 5 minutes, a little bit slow. A-bomb doesn't have anything to worry about from me. So I think I'm going to drill and counterbore first, and then we'll start with the knurling, which is going to be a bit of an experiment. That was a beginner's error right there. All the lubricant and all the brass bits in there, it seems like it's covered in gold, doesn't it? Can't see that, sorry. That's actually pretty reasonable. It's a good fit there. All right, so this part will be fixed from rotating, so the bearing won't spin around. When I drill and tap this with the screw that's going to be the tightening adjust and centering control. But anyways, right now it's sort of married, but we'll fix that. All right, just got a bunch more to do. This was my test. So these guys, and the way they mate with the cast body, I cut the hole very closely, and the 1-inch bit did not do a perfectly straight, make a perfectly straight hole. It was off by 1/1000th or two. And when you have 1/1000th or two of perpendicularity or coaxially with the threaded and bored part, then a couple thousandths here magnifies and becomes more than that down here. So when you're trying to tighten these in, these were binding up. So my solution was to use an adjustable reamer. So I was reaming out the 1-inch hole just a few thousandths. First of all, to remove the score marks. I don't know if you can see. No, you can't. To remove the score marks, and second of all, to make it so that there'd be a little more latitude, so that I would be able to tighten the brass bit in and not have it bind up like it was. I mean, I could get it in. It was tight towards the end because my problem was I made the tolerances too tight everywhere within 1/1000th, like the inner diameter of the brass piece here was only 2/1000ths larger than this rod, so it fit really snugly. It was pistoning, but it didn't allow enough latitude, so I've moved it so there's just a tiny bit of wiggle, and as a result I can tighten it all the way up. So that's where I'm at. So I'm about to do the machining on the bearing holders, and I need to cut the 30-degree bevels on it to allow clearance for the bearing. I also need to drill a slot, which you can't see here, that'll allow the bearing to seat into it, and the cross hole for the pin that'll hold the bearing. So these 30-degree angles, it's just clearance, it's not a critical depth. So I use the CAD program to calculate the depth here rather than doing the trig myself. And it comes out to about 0.52 is the depth. So in order to set that on here so I can eyeball it when I'm cutting it on the mill, I am going to come over here to the lathe, measure over 0.52 and score a line all the way around. That way, when I get over here and mount the piece of steel in here, I'll have a mark. I'll just bring this over until the cut just touches the line I've drawn, and that way it'll be approximately correct, close enough for what I'm trying to do here. Alright, so let's start with scoring the line. So there are many ways to do this. I could do this sitting on the surface plate with a height gauge, but you know, when you have equipment that auto centers and that has DROs built in, there are some easier solutions. So here we are setting 0, and we'll come up here and set my 0 on the Z-axis. Come back here, pull the cutter out, go down to 0.52. Set to 0.52. Have my lathe in neutral, so it rotates freely, and we'll just lightly touch with the cutter and spin. And let's see if I can get you in there. There's the line. So then we'll take this over to the mill and cut the two flats and see how close we can get to this line. So here I am with the part in place, and you can see right here is my mark. I am going to move this back and just cross the cutter back and forth until the cut just reaches this line here. And then I will use the indexing feature on this guy to rotate 180, do the same thing. Then I have to take this whole piece off, mount it on the flat part here of the table, and then we'll cut the slot for the bearing and flip it 90 and drill for the pin, drill and ream for the pin, and then repeat as necessary. All right, so let's take a couple light passes and see what we get. set my Y0 on the DRO now that I've dialed it in. And now we're just going to rotate this guy over 180. There you can see it's pretty close to the line. It's almost right on. That should be 180. Rinse and repeat. So now I'm going to push this out and I can just come back to my 0 point. Since this is symmetrical, I don't have to keep checking the line so carefully. So that was the last pass for this side. I can't take it easily out to show you because I have to keep this orientation, this rotation orientation, fixed. So I got to keep this guy locked and be very careful about that. So here's my next setup, and we'll be doing the slot this way for the bearing. And then finally we will turn it sideways and drill the hole through this guy for the pin that will hold the bearing. And I'll have to turn this sideways. There's more setups in this project than I've ever done before. It's crazy. And then I have to repeat this whole thing 2 more times. And I can't just do one step, come back, do another step, come back, and do another step, you know, do all 3 in a row, because I'll lose my reference. So it has to be done all at one time. Basically, move this thing 3 times for each piece. Fun. So I'm going to set my Z-axis depth by just touching off gently. That is it. And so this is my 0 point on my X. But this is 250 thousandths. The total width needs to be 300 thousandths. So I need to go plus or minus 25 thousandths after I'm all said and done. And the depth is nearly 1 inch. So here's a little over 100 thousandths pass. Looks good. Oh, actually, that was only 15 thousandths fast. I lied to you. This is a 1/4 inch cutter, so that was really, really light. Try a 50 thousandths pass, see how it goes. This also is a high flute count cutter. So it's not good for roughing. I don't think I have any 1/4 inch roughing end mill, so. Pass for the final depth, and then we got to go wide. So to do the final depth, do the final width, I'm going to have to come part way. I don't want to take this whole cutter and try and take the wall, especially since there's no cutter up here. I don't think it even has a full inch of cut. So we're going to do it in pieces. So I'm going to go over 25 thousandths and then do like 250 thousandths passes, 25 deep on each side. So I've oriented this so you can see it. So the bearing will go in here and stick out about like that. So the bearing has more than 180 degrees of touching without impact, without running into the holder. It was sort of a compromise because I wanted to make sure I had the maximum amount of meat holding it in place. So Second to last step, we're going to drill and ream for the pin that'll hold the bearing that sits in here. And last part will be to do the flat on the top part. We're going to do a 1/1000th interference fit. Fast. And that's it. Move on to the next one, and then we'll come back and do all three with the flats on top. Alright, so just a few steps to go. The next step is to mill a flat that is parallel to the slot in here. And it's going to go from just a little under an inch here to just over an inch on this side. And it's so that the tightening screws that are going to lock these off can also prevent it from rotating. I originally was going to do a deep slot, but I decided I prefer a flat instead. So to set up this in my vise, the first thing I did was I used my vise stop that I made a few projects ago to set the back side of this so I can do all three of these quickly. Then to get the top so that it is flat relative to the slot, I machined a piece of aluminum that just fits the slot, and I take my micrometer and I make both sides exactly the same, and that way it won't be tilted. It'll be parallel to the vise face, and then when I machine it, it should be parallel as well. So Unimite comes in handy again. Highly recommend one. So I still need to set my zeros on my DROs, so I've used my stop to find the end here, and then move 100,000th in to compensate for the 200,000th diameter, then found both sides to find the dead center, and that way I can get my measurements the same and repeatably. So next up, milling. So what I'm looking for is a pad, a flat spot here that's wider than the 3/8 inch screw I'm going to use. I originally planned on 1/4 inch, but quarter 20, but I think I'm going 3/8 16. I want a little more bearing surface and a little more force to lock these off. So I'm going to go down 50 thousandths first go. So I'm going to come in here. Wow, that's a big bite. I had no idea. Look at that. So let's come back here to 0. Shooting for 4 inches. I know it's a trick I've shown before, but I only wanted to use my 1/8 inch parallels. So to hold them in place, just toss a couple springs in there. When you start to close it just a little bit, it holds them in place. If I had longer ones, I'd use those. Nice trick to keep your parallels from moving. So I'm on my final stage before assembly here, and I need to drill and tap these for 3/8 16 for the lockdown which is one of these guys here. And the issue I have is lining this up. So I had that problem from the beginning, and I thought originally I was going to try and mill flats on the sides of this so that I could indicate off of it to get center, but I was never able to set this up so that I could get a substantial portion flat. So I realized the center column is actually pretty straight. However, originally I bored this to 1 inch 2/1000ths, so it just fit snugly, but that was way too tight. So what I had to do was open it up with a reamer a little bit to 1 inch and about 14/1000ths, because a slight angle difference between how this got bored between the threaded part in this, or drilled rather, it wandered like a fraction of a degree, but it was enough so that it rubbed. So what I'm going to have to do is I figured I'm going to create a piece like this that'll fit inside here, and I can indicate off of its sides to find to make sure this is square, to work back about 1 inch from here, or 3/4 of an inch from here for the thread screw down. So the tightening screw. So that's what my plan is. So we're going to take this piece of aluminum, we're going to turn it down to about 1 inch 12/1000ths or so, and make it so that I have something to align off of in order to get dead center on this part here. All right, so what we're doing here is I'm taking off 1/2 inch roughly. It's going to actually be a little less. 150,000 steps a cut. Chip breaker works well when you take a big bite like this. Skim pass to make sure it's concentrically round, and then we'll be good to use it in our setup. So I know this is tight, so I hope you can see it. So the aluminum bar goes in the 1 inch bore, the slightly over 1 inch bore, and I'm using it to make sure that I am square. Once I'm square, I can put my indicator, find the center of this bar, and that will be the center of the hole, and then I can find this edge over here and go in 3/4 of an inch. So that was my plan, and this is the easiest one because with this one I had 2 flats to line up with the ways, so I was really close right off the bat. I was within like 5/1000ths, 10/1000ths actually. The other one's going to be much harder because there's 60-degree angles, so I might bring you back if the setup's a little bit different. So for the setup for the other guy with the 260-degree angles, the bottom side, I thought you might find this interesting, so I brought you back. In order to rough it in before I start with the aluminum cylinder and the dial gauge, I took my square in the ways, which it happens to fit really nicely down the ways here, and a 30, 60, 90 triangle, and got this as close to 60 degrees as I could. I'll bring you back when I get the dial indicator on it just to see how close I actually got. So over roughly 6 inches, we were off 25/1000ths. So now I'm going to tap it into place and get it as close to exactly right as I can. Alright, so here we are, we're really close, within a couple thousandths over 6 inches. So this isn't an ultra precise thing, and I can get a little bit of way movement, so the gibs are pretty tight, but see, I can get a little bit of way movement. So as I'm tapping with the hammer, it does move the ways a little bit. So you see now it's all about, so that's a 0, so I'm about 2/1000ths. So we're gonna go with that, and next I will find the center of this and find this edge and then do my drilling. I'll bring you back when I'm done. So it's been a really long road. Here we are getting very close to the end. Now it's just left as assembly, so I've got to take pin, bearing, put it in the ends of these guys, then mount these guys into here with a screw, and then thread that whole thing in, put the handles on, the tightening handles, assemble the two pieces held together with those Allen bolts, and finally hold this guy down to the lathe. And I think we're going to try this whole thing out just with a test piece of stock and see how it works. So let's start with putting the bearings in these guys. So we're just going to use an arbor press, this guy right here. It's a small arbor press, to press these pins in. They're a 1,000th interference fit. They're pretty tight on the bearings as well. And we're just going to repeat that 3 times. So that's pretty much what's going to happen. I'll bring you back. So next step, insert these guys. I can keep them oriented properly by putting the hold downs on them, or in place. Got the hold downs from McMaster-Carr. I got most of the hardware from McMaster-Carr. They really are an amazing supplier. All right, next. So here it is assembled, so let's pop over to the lathe and test it out so we can see how well it works. Okay, so here's the Steadyrest in the 3-jaw chuck. I've centered it up. This particular piece of material is really out of round, so as a test I'm just going to face it, and we're going to start at a really slow RPM, see what we can do, see what it can handle, see how smooth it is. Don't want to risk anything right now. So I'm facing this very out of round, not square cylinder. RPM. You can see how out of round this piece is. There's a 25,000th depth of cut, 3.3 thousandths per revolution advancement. There's 180 RPM, 25 thousandths depth of cut. Good. These bearings are pretty darn good. These bearings are designed for several thousand RPM, and I chose the highest load that I could find for the size. So another thing I noticed is A-Bomb has a very good point. You got to be careful to keep chips out of the bearing areas. I got one in there earlier and it scored this pretty good. So definitely something to watch out for. I'm going to try a longitudinal cut after this just to see how it works. 50 thousandths cut, longitudinal, 50 thousandths depth of cut, 3.3 thousandths. Oh, that's not good. So here's an observation. It's okay having these on this side. I figured it'd be fine because you'd probably have a much longer piece. But if you want to be able to get the sled close up to this guy, although that is a problem, I have to use the compound to do that because this part here runs into this. Before it ever gets close. So with the compound I can get closer. So I might want to make it so that these are available on both sides. So tap and thread for both sides. That way if I need to move these to the other side to get closer, I can. I don't know if that's really essential. I'll think about that some more, but that's a thought anyways. So yeah, it works pretty well. Not much vibration, goes pretty high RPMs. I talked originally about painting it, but I think it looks really nice in just plain metal. It'll probably rust at some point, but I live in Southern California, so that's not typically a huge problem. So thanks for watching. Hope to see you next time.